Every time you check a bank balance, stream a movie, or book a flight, you rely on unseen software updates happening in the background. Building an application from scratch happens in a vacuum. Injecting new code into an active, running system requires a much higher level of precision. In a live production environment, real customers are actively moving data and executing transactions. A single typographical error in a new line of code can immediately lock out thousands of users or corrupt active databases. Pushing modifications to a live system without stringent controls is the technological equivalent of attempting to swap out a car's engine while driving 70 miles an hour down the interstate. When untested code slips into a production environment, internal servers crash, external screens go blank, and core business operations stop. Even routine maintenance carries risk. A standard security patch designed to protect a database might accidentally sever the connection to a payment processor, freezing corporate revenue. Then there is the data itself. Untracked manual modifications by an administrator can alter financial records or expose sensitive personal information, triggering immediate compliance violations and heavy regulatory fines. To stop the bleeding, IT teams drop all planned projects to diagnose the failure and trace the bad code, a process of emergency rework that drains budgets and exhausts engineering resources. Without a management framework to guide these updates, the same engineers hired to maintain a system can inadvertently become the primary threat to its availability. To neutralize these hazards, organizations rely on a systematic defensive shield known as change management. Safe software deployment relies on absolute isolation. Code is never written and deployed in the same environment. It begins in development, a sandbox to experiment freely, walled off from operations. Then it moves to testing, facing simulated conditions to expose hidden flaws. Technological isolation requires a human counterpart, the security principle of segregation of duties. To prevent human error or intentional sabotage, the individual who programs the update is barred from migrating that change into the live production environment. By isolating the digital environments and dividing the human permissions, the organization removes the risk of a single point of failure destroying the live system. Even when code is fully tested, it must pass one final oversight committee, the Change Advisory Board, or CAB. This board reviews every proposed modification. They verify a legitimate business purpose, assess the cross-department impact, and finalize the rollout schedule. In a large enterprise, different departments might unknowingly attempt to deploy incompatible code at the same time, which can lead to system-wide crashes. The CAB acts as central air traffic control, sequencing these digital deployments so they never collide. And if an approved, tested update still fails in the real world, the team relies on a mandatory safety net, the rollback plan. This protocol allows engineers to instantly yank the failing code and revert the system back to its previous stable state, keeping downtime to a minimum. Oversight paired with rigorous rollback contingencies transforms software updates from high-risk gambles into calculated, reversible procedures. When change management operates effectively, it is invisible to the end user. The systems simply work. This operational stability frees IT personnel from constantly fighting digital fires. Instead of wasting cycles on unplanned emergency rework, they can focus on initiatives that help the business grow. The reliance on stable, centralized computing spans decades, beginning with massive mainframes that ran the core functions of global enterprise. Today, that challenge has scaled. In an era built on automated cloud infrastructure and complex, interconnected APIs, a single untested code change can propagate across global networks in milliseconds. Rigorous IT change management is often mistaken for bureaucratic red tape. In reality, it provides the structural stability required for an organization to remain resilient and secure.